Hello everyone. We have seen bearing capacity formula given by Tarjagi and Meyerhoff. In this video, we will see the codal provision for bearing capacity. So IS code formula as per IS 6403, you have the bearing capacity equation. So the net ultimate bearing capacity equation is given as Q Nu equal to C Nc into shape factor, depth factor, inclination factor plus Q bar into NQ minus 1, then shape factor, depth factor and inclination factor, where Q bar is the effective surcharge plus 0.5 gamma B N gamma into shape factor S gamma, depth factor D gamma, inclination factor I gamma into water table correction factor. So this is the expression for net ultimate bearing capacity equation for any shallow foundation, where C is the cohesion parameter, NC you know, NC, NQ and N gamma, as you know, are bearing capacity factors which are the function of phi, shape factor SC, DC, IC, shape factor SC, depth factor DC and inclination factor IC. These factors are given in IS 6403 that can be obtained. So let's write what are the shape factors. So SC as per our codal provision is given as 1 plus 0.2 B by L for rectangular footing. So if the footing is rectangular, you should take 1 plus 0.2 B by L equal to 1.3 for squared footing. If the footing is other than rectangular, then you should take it 1.3, or if it is a circular footing. Right? And if it is a strip footing, the value will be 1 for a strip footing. Right? So you are having another shape factor is here, SQ. So SQ is also similar to SC, 1 plus 0.2 B by L for rectangular footing, and here 1.2 for square oblique circular. So SQ you can find it out, and 1 for strip footing. Similar to this. Another shape factor is here, so you should know S gamma equal to 1 minus 0.4 into B by L for rectangular footing, and it is 0.8 for a square footing, and 0.6 for circular footing. So easily you can remember it, right? And 1 for strip footing. It can be remembered very easily. The depth factor DC, as you know, is calculated as 1 plus 0.2. It's a depth factor, so depth of the footing divided by B into tan 45 plus 5 by 2, where phi is the angle of friction, all of you know it, and the depth factor dq equal to d gamma dq d gamma, that you can calculate it as 1 plus 0.1 d by b into tan 45 plus pi by 2 for phi greater than 10 degree. So this you should remember it, dq d gamma, and it is going to be 1 for equal to 1 for phi less than 10 degree. So if the value of phi is less than 10 degree, then the value will be 1. So this way you can calculate out the depth factor. Now what about the inclination factor? So inclination factors can be computed. We can write the inclination factors also. What are the inclination factor? IC, IQ and I gamma. So this IC and IQ, these inclination factors are given as 1 minus alpha divided by 90 degree, alpha will be in degree whole square. So if you have a footing and the load is going to be inclined, making with the vertical an angle alpha like this, you can calculate IC, IQ by using this expression, and I gamma in the last term you have got I gamma is given as 1 minus alpha by phi, where phi is the angle of friction, whole square, where both alpha and phi will be in degrees. So all things you can find it out. And the last term, this one, is called water table correction factor. So W prime is called water table correction factor to be applied to the last term. So if you have a footing, this footing Here the water table is below the base of the footing, and let's say from the base of this footing the water table is at a depth dW. This is the groundwater table, and it is from the base of the footing at a depth of dW. Then the water table correction factor, therefore the water table correction factor W dash equal to 0.5 into 1 plus this depth of water table from the base of the footing divided by B, width of the footing. You can calculate it. So when dW becomes 0, that means groundwater table is touching the base of the footing, this term becomes 0, and water table correction factor will be 0.5. And if dW is at a depth B or greater than B, then this term should be taken as 1 plus 1 equal to 2 multiplied by 0.5. So maximum value of W prime will be 1. So this can be calculated like this. So this is the one very important formula for net ultimate bearing capacity given in IS code. Thank you very much.